So today we're going to be framing out the control room for the new studio. Now because this is a room within a room design, we are going to be framing out the inner room today. So that includes both the walls and the ceiling. So let me show you guys how I do this.
True Sound Studios is in your ears.
Okay, so the first thing we do before we put up all of our insulation that's going to be on our outer room. This is right on the other side of this plywood is the outside. Where this piece of plywood met this piece of plywood, there's a gap, and some of the gaps were bigger than I would probably want, but I didn't build this. So I went ahead and spray foamed it all. Now, if the gap is smaller, then you'd want to use an acoustic caulking, but some of these gaps are just so big, I'd have to use so much acoustic caulking to stop it. Spray foam is great because if air can move through it, then sound can move through it. So we really just want to seal up all these holes. So if you can use acoustic caulking over spray foam, but sometimes you don't have a choice because of how big the gap is. So that's one area where I went ahead and sealed up all this. Now we're going to take a look at a couple other different situations where spray foaming probably isn't the best case scenario. Okay, so another equally as large gap. I mean, this one, that's a full finger you can get in there. That's a huge gap. That's because the previous owner had drywalled the walls first and then did the ceiling. So when I took the walls out to be able to seal and insulate and all that, only thing to do for something like this is to go ahead and spray foam this. And then before any of that sets up, I'm gonna take another piece of drywall about 4.5 inches wide and just mush it up here to help the spray foam have somewhere to actually adhere to on the bottom. And then also to create our mass and make up that drywall gap by putting more drywall up there. And then I'll just screw it to the top, and then we can, fill in this giant void. Now this void runs half the garage, so it's 2 of the 4 walls, so it definitely needs to be dealt with. Okay, so first it's gonna go ahead and start spray foaming this. That looks pretty good, so now I'm just gonna mush this in here with another piece of drywall. You can see we really cleaned up that whole gap now. And then I'll just go ahead and screw it to the ceiling here. Now you do want to make sure you try to hit some studs. So I'm just going to keep putting screws in here, maybe every 12 inches. Yeah, I'm just going to keep going and finish up the rest of the garage. So as you can see, I went ahead and filled in all those gaps in the drywall and the ceiling with more drywall. And on the seams, I used the acoustic caulking. Additionally, anything else that had seams in it, as you can see, I used the acoustic caulking on like the corners, any holes in the plywood at all. And then also down here, that's all acoustic caulking that is really sealing that bottom plate to that plywood. Okay, so now that these walls are fully prepped, now I can go ahead and start adding the insulation. So the insulation I chose for this is Owens Corning now makes their own version of a Roxol. It's called Thermofiber. It is a mineral wool. It is essentially just like that Roxol. It's an R15, so it's great for the R value, but it's also dense like the Roxol is, so it just kind of helps attenuate that sound a little bit more than fiberglass. It's kind of a difficult decision to go between fiberglass or the Roxol. The Roxol is a little better for exterior walls. If these two walls weren't exterior walls, though, I would have done just straight fiberglass, but pests like fiberglass better, so exterior walls, you don't want that as much if possible. And then the other reason is fiberglass doesn't do as well with moisture. This mineral wool insulation does much better with allowing moisture to dry up and not rot out the sheathing or cause mold or issues. So anyways, it's time to start putting in some insulation. Okay, so this is a couple bags of insulation up. I left the R15 out. At least my town is very picky on what the insulation value of the actual wall assembly is. I need to be at R21 in this town it's going to be an R28 in the end. So obviously that's over code. Yeah, so I've just been installing this. Not every cavity is obviously 14.5 inches, especially with windows and stuff like that. So I'm cutting that out using one of these. This is this insulation knife. I went and bought this because my bread knife, which is what I usually use, I just can't find it. So yeah, just you can use a bread knife, or you can actually buy an insulation knife just to cut this stuff. It kind of cuts like styrofoam cardboard type. So yeah, so now let's kind of continue the rest of this this wall and obviously all the rest of them. I'm wearing a HVAC suit with a respirator. Yeah, just gonna keep going. Okay, so the entire exterior has been sealed up, and then after that I went ahead and put in all this mineral wool insulation, and I used 24 bags in total to do this entire space, so it's a pretty big space. Now, I think something that's very interesting is you would think with 24 bags of insulation that you would, have a fairly good treated space, but I've only treated the walls. And I just want you to take a listen to something. I'm gonna do the clap test. You hear that ping-ponging, bang, bang, it sounds like a spring. That's the sound hitting the ceiling and then hitting the floor and then going back and forth because they're parallel surfaces and they have not been treated, which just brings me to my point. When you have your finished space, when it's all drywalled and everything, you really need to pay attention to the ceiling and the floor, because chances are they're gonna be parallel and they're gonna create that ping-ponging noise. So you definitely wanna put acoustic treatment on the ceiling and then maybe put a rug on the floor to help cut down on that, because that sound is not a space that I could go ahead and mix in. Okay, so fortunately, this is not the final space. Now we're gonna create the inner room. So I'm essentially going to build another room just inside of here. Be one, which will be like the vocal booth, and then the other space, which is the main control room. And we're gonna actually make this room will be even smaller because we need to leave a little space between the two sets of studs. The ceiling height will drop a little bit, the floor will have to come up to be insulated, the walls have to come in just a little bit. So we're gonna lose about 10 inches all the way around here. And that's to help stop sound from transferring. So I don't wanna hear those cars or whatever outside of the space while I'm in here mixing or recording, and vice versa. I don't want the people hearing me play music at 2 a.m., my neighbors or even my wife. So yeah, that's the next step here. I get to go ahead, gonna start bringing in treated lumber, put that on the floor first, and then go ahead and build our walls. Bring in those big LVL, those big beams to finish out the ceiling, and then we can start progressing and get even further by adding the drywall and the green glue, and then obviously acoustically treat the space, and there's a lot of stuff to do. So let's go ahead and start framing out these inner walls. As you can see, I brought in all the lumber so we can actually get started. So I got a whole bunch of different stuff. We got 2x4x12s. That's going to be a lot of the top and bottom plates. These big guys, these are 2x6x14s. That is for mainly the ceiling, along with these 2x6x8s. We want all these walls to float on rubber. So let's go ahead and take a look at what I did and used to isolate these inner walls by using a rubber mat that I bought for $40. So let's go take a look at that. Okay, so what I have here is a piece of rubber. Now this is 3/4 inch thick. What I did is I bought a 4x6 foot rubber mat. It's called a stall mat. What I did is because it has these grooves in it, kind of made it easy to cut. And I cut these into widths that will work for my 2x4s. And this will sit on the concrete, and then my 2x4 walls will sit on top of it like that. And what this does is this piece of rubber isolates that inner room. So essentially that impact noise, that sound mechanical vibration that's going to be vibrating that room, this is going to help isolate it. Now, you can buy these pre-made. They're called U-boats, but they're like $3 to $4 a piece. And I figured I would need quite a few of them. So it was gonna be like $400 or $500. Now that stall mat, I cut these myself. It took me about, maybe 20 minutes to cut about 40 of them. and it only cost me $40. This is a really cheap way to do it. So rubber is essentially kind of like a spring. Think about this. You took your Toyota Corolla, and there's springs that help with the suspension on your car that helps absorb some of the shock from the road so it doesn't transfer to the actual car itself. Now, what if you took springs from like a big moving truck or something? So if you took that big spring and put it in your little car, those springs would pretty much never move because it's taking too much pressure to compress those springs and there's not enough weight. Now that same concept works with rubber. If what I'm putting on this piece of rubber isn't heavy enough to actually compact it, this rubber isn't really going to do much. And if we do the total opposite, if I put so much weight on here that it actually kind of like mushes all together, it's like having a totally compressed spring. It's not going to absorb any of that mechanical shock. So we need to come up with a way to try to figure out the compression rate of this piece of rubber. So you still need to come up with a formula that's going to tell you how far apart to put these and where. Now, I'm not going to tell you guys where to put them because every situation is going to be different. Nobody's going to have these exact same dimensions or use the same materials. You know, I'm sure there's some formula or website out there that'll help you out with that, or maybe you guys can hire somebody. So I'm gonna start building this. We're gonna put the rubber down, we're gonna put the treated lumber on top of this, and we're gonna start framing our walls. Okay, so the distance from our inner stud to our outer. So 1 is considered the absolute minimum distance you should have between these 2 studs. 2 is recommended. I'm gonna do 3 inches just because nobody's ever gonna notice, you know, in total 2 inches less in this entire studio. So from the very edge of this stud to here is going to be 3 inches. It's going to be the same thing from here to here and all the way around the entire room. Okay guys, so as you can see, I got the first wall built here, and it is it's pretty strong. It can hold me up. But with the spacing, this is actually 24-inch spacing on center. So the center of one board to the center of the other is 24 inches. But because this is supporting nothing more than drywall, it's not like it's carrying the load of a second story or anything like that. We can do 24 on center, plus to get that STC rating, so that's the rating that I'm going for is somewhere around a 70 STC rating, and they recommend a 24 on center wall. You can see behind me this outer wall that you know, is essentially is the finished space of my house. This is actually 16 on center, and then here we have 24. So yeah, so I got this one wall. I still got to do this doorway, but because we have to bring in those massive beams through here, I definitely want to leave that open for right now to give me the most amount of space. And then just keep going around here, and we will soon have a control room that is framed out. Okay, so we're up here framing all these walls. Up here though, you can see there's 2 pieces of wood. This is known as a double top plate. So you got your stud that's carrying the wall, and then this top plate up here has 2 pieces of wood. The reason I had to do a double top plate, even though this is a non-load bearing wall, is because this is 24 on center. Our ceiling joists are going to be 16 on center. So some points, these ceiling joists will sit on a spot where there isn't a stud, and we don't want that to sag over time, so you just do a double top plate. So that's the reason for that. Okay, so it is day, I think 3, I guess you would call it day 3. And the entire control room has been framed. So the only thing I'm missing is obviously the ceiling joist, because it still needs to be another ceiling. And later on today, I need some help. There are these 21-foot long beams that we have to put in. There's 4 of them. They're known as LVLs, essentially like plywood layers laminated all together, glued together. And it creates these really, really strong beams, stronger than your traditional piece of lumber, you know, a solid piece of timber. So those will go in later today, and then I can put all the ceiling joists across there. And it's because of that big I-beam that's actually holding up the outer structure. We have to work around that. So now I can start working on the drum room, vocal booth, live room, whatever you want to call it. So that space back there is about 15 feet long. It's about 8 feet wide, and it will have, I think it's about 9-foot ceilings. Okay, so we got these big LVL beams in. Anyways, there's 2 of them. These are 9.5 inch. They're 22 feet long. I had to cut them down just a little bit, but there's actually 2. There's one here, and there's another one right here, and they're sandwiched together using these Simpson strong tie, these monster screws, so that they combine together to create even one thicker beam. And then right now I'm putting these hangers on here. This is what our 2x6 ceiling joist sits into and spans all the way across. And the reason I had to do these LVLs is because our ceiling joist would normally run across, and if this beam wasn't here holding up the actual structure, they would just run right through to the other side. Because that isn't the case, they run from one side to here, and then there's actually 2 more LVLs on the other side of here, and that picks up the rest of the ceiling joist to the final wall. You know, obviously it's not a perfect situation. I would have loved to not have this beam here, but you know, you work with what you have. So anyways, I'm going to continue throwing these hangers on here so we can put the ceiling joists up. Alright, just going to show you quickly how I put these hangers up. First of all, I measured 16 on center all the way down this entire beam, made a mark, and then used a speed square to make a line. I got the laser level set up here. You can see this red line, and that's just showing me where the bottom of the joist needs to go, which also kind of correlates to where the bottom of this hanger. This is how the hanger goes on. We want to get that black line right in the center of it. And then we're going to use some of our Simpson screws here, and I'm going to put a 2.5 inch one through the bottom. And that's so we can make sure we couple both of the LVLs together. We can throw another 2.5 inch at the other bottom hole here. And then there you go. And then after the joist goes in, there's actually 2 screws on each side, and that's got to be 2.5 inch. That pulls the ceiling joist together as well as anchor it to the LVL. Okay, so we're getting there. Finally, all the ceiling joists are in on this side and this side of this large beam here. All the LVLs are in. It's all screwed in. It is ready to go. And now I can finally go ahead and start the live room. So some more things I just got from Elite Core. That's the manufacturer of this cable. I needed 12 channels at like 24 feet long to go for the drums area. So 12 channels at 24 feet. And then I needed, I think it was 6 channels at 47 feet. And buying those 2 cables separately was gonna be like over $200. So instead, I bought 100 feet of 8 channels from Elite Core, and I think it was $126. $75, $80 cheaper just to buy a big long cord that I gotta obviously cut and solder ends on. But I got this, which is great because before I can put the drywall up, obviously all the wiring, all the rough wiring needs to be done. And it was very important that I got this. Okay, so I am up here in the attic, and what I'm doing is I'm hooking up the heating and cooling system that's going to be in the studio, so both in the control room and in the live space. And the type of heating and cooling we went with is called a ductless system, no ducts, so none of those big, you know, steel or galvanized ducts running through the whole house. We wanted to finish the basement, and a ducted system would it just wasn't an option for us. It was too expensive. The whole system is essentially just run off of copper pipe and a control wire. There's 2 copper pipes per unit. One is the supply, the other is the return, and that essentially feeds all the heating and cooling for the entire house to every single room. So that's what I'm doing right now. And I need to hook up 2 units. So like I said, there's one for the control room, one for the live room. So it means 4 copper insulated lines. Each unit has to have a drip or a drain line to just, when the condensate forms, that water needs to get out. And additionally, both of them have a control wire. So that is what I'm working on right now. So these are the insulated copper lines that I was telling you about. And there is a supply and then a return for each one of the units. You can see here, this is a distribution box. Allows you to hook up 4 units. So you can have 4 indoor units connected to 1 outdoor. And then there's, way down there's actually a second one so that we can have a total of 8 units connected to our system. So just a real quick detailed look. What you do is you cut the copper line with a pipe cutter, and then you have to use a separate tool to flare the end like this so that it fits onto your copper fitting, and then you just tighten this up, and then obviously tighten it down to their specs. And then this is the other one. This is the return line. It's just a smaller line. At some other point I will show you guys the units when they're actually hooked up, but this is part of the rough install, is running all these lines. And then lastly, this is the wire. This is 14-4 stranded wire. So you got your ground, and then you got a neutral, and then a hot and a secondary line. And this is all the power that is fed to each one of the units, and that is really it. Okay, so you guys have seen the framing of the control room, obviously all the insulation we put on those outer walls, and then the beginning of the heating and cooling system. So in the next video, I'm gonna go ahead and frame out that live room, and then we'll also get into some more of the heating and cooling, because we need to let the air flow through both of the studio spaces, but we need to stop the sound from transmitting between the 2 spaces. And then also we're gonna get into some of the wiring of all the mic connections and all that stuff, so that we eventually can insulate those inner walls and then ultimately drywall that space. All right guys, as always, thanks for watching, and this is obviously going to be a big series of videos, so if you guys have any questions, please feel free to leave them in the comments. So thank you for watching this video. If you guys enjoyed this video, click that like button and consider subscribing for more content. So not only do I make YouTube videos, but I also produce tracks, and I can mix and master your music. So once again, thank you for watching this video. I'm Weezna, and True Sound Studios is in your ears.